Welcome, Wildcats. Today we're going to be looking at the next section of your HRW homework assignment, which is section 4.5, titled Factoring Polynomials. Now, we've been working on addition, subtraction, multiplication, and division. The reason we focused so hard on those was because of how important factoring is for the rest of the year and how you have to know how to add, subtract, multiply, and divide really well in order to do decent on the factoring. So, let's take a look at how factoring polynomials works in a variety of different situations. First one that we're going to look at is when all the different terms of the polynomial actually have one factor in common. So we start by factoring out the greatest common monomial. So take a look at this one, 2x cubed minus 30x. Well, hopefully you guys can take one look at that and notice that both of the numbers, the 2 and the 30, are even. Therefore, they're both divisible by 2. Both terms have at least one x in it. In the first one you have 3 because it's x cubed, and in the second one you just have a single x. That means we can factor out an x and we can factor out a 2 because both terms share a 2 and at least one x. When we factor these out, we pull out 2x and then we divide each term by what we're pulling out. So we have a 2x on the outside, and then inside the parentheses 2x cubed divided by 2x is x squared, and negative 30x divided by 2x is negative 15. Once you're done factoring those out, in this case you're done with the problem, because when we look at x squared and negative 15, that doesn't factor. There is no way to factor that. However, you won't always be done after factoring out the greatest common monomial. The second method that we want to take a look at is how to factor by grouping. Now this is a special case when you have a polynomial with 4 terms. When you have it, you're going to factor a monomial out of the first 2 terms and a monomial out of the second 2 terms. So in this case, looking at the first 2 terms, x to the 4th and 2x cubed, what monomial is the largest thing that both share? With luck, you saw that they're not both even, so they both don't, there's no number that they both share, but they both have x's, and the largest number that both have is 3, because the first one has 4, but the second one only has 3. So we'll be able to pull out an x cubed. Now when you look at the second 2 terms, 8x and 16, what's the largest thing that they both share? Once again, hopefully you see that since the 16 doesn't have an x term, there can't be an x that they share, but they are both multiples of the number 8. So when we factor these out, we're going to factor out x cubed from the first 2, and we're going to factor out 8 from the second 2. And it's going to look like this. X cubed pulls out, leaving us with x plus 2. And then when we pull the 8 out, that leaves us with x plus 2. Notice as we regroup these, the x plus 2's stay together, and we can also keep the x cubed plus 8 together, meaning we're left with x cubed plus 8 and x plus 2. Moving on, I would like to point out that tomorrow we're going to talk about the special rule, but x cubed plus 8 can actually be factored. It is a sum of cubes, and we're going to talk about how to factor it tomorrow. For now, this is where we have to end our factoring of this problem because we don't know how to go any further yet. Just know that sometimes once you're done factoring out a monomial, or when you're done grouping, or when you're done with the third type that we're going to talk about, which is factoring by dividing, you may not be done yet. There may still be another thing that you can factor out. So when we're going to factor by dividing, we're going to talk about the rational root theorem to check for our zeros. Now, you don't need to remember the term rational root theorem, but it is useful to know how to use it even if you don't remember what it is. So, in this example, we notice that all of our terms have at least one x, so we can factor an x out. But hopefully you also notice that 3, 6, 15, and 18 are all also multiples of 3. So we're actually going to factor out a 3x first. That leaves us with x cubed plus 2x squared minus 5x minus 6. So what we're going to do with this is we're actually going to look at the constant term. That's that negative 6 at the end. And figure out what all the different factors of that are. Well, the factors of 6 are 1, 2, 3, and 6. And then we need both the positive and negative versions of both of those. So we actually end up with quite a few factors. Next, we need the factors of our leading coefficient. Hopefully you'll remember that in standard form, that's just the number out front. In the case of x cubed, that coefficient is simply 1. And again, we need the positive and negative versions of it. Now, what the rational root theorem actually says is that if you take one of those numbers up top, so one of the factors of the constant term, and divide it by one of the factors of the leading coefficient, those are all the possible outcomes that will give you an actual factor. So that means if we were to actually do the whole theorem, you would have to take 1 divided by 1, 1 divided by negative 1, negative 1 divided by 1. Now you are going to get some repeats in there. What that means though is we actually have fewer things to check than it looks like. So what I like to do is I like to start at the small end and use synthetic division to check. So using synthetic division, the coefficients of our polynomial are 1, 2, negative 5, and negative 6. And we have to decide which one of these possible ones that we want to check, which one do we want to start with. Personally, I like starting on the small side, and I like starting opposite of what the leading term is. So our leading term is a positive 1. So that means I want to start with a negative, and if I want to start on the small side, well, 1 divided by 1 is 1, so we're going to start by checking a negative 1. So with synthetic division, as you guys know, drop straight down, multiply. 2 minus 1 is 1. Multiply by negative 1 again to get negative 1. Negative 5 minus 1 is negative 6. Multiply by negative 1 gives us 6. And negative 6 plus 6 gives us 0. And that is what we're looking for. If you get a 0 as your last term, remember that means you have no remainder. That also means that this is a factor. Negative 1 is a factor. So that means that what we have to pull out is the opposite of that, so we're going to pull out an x plus 1. So when we rewrite our new factors, we keep that 3x, that first monomial that we pulled out. Now we know that we've got x plus 1 as well, but we've also got our row here. That's going to be another polynomial that we have to write in. So since we started with x cubed, that's going to be x squared plus x minus 6. So we have our 3x, our x plus 1, and our x squared plus x minus 6. Our final step here, because we're not quite done yet, is to factor our trinomial. Now there are several ways to go about this. We can still actually use the rational root theorem because those are still all the possible zeros. And since we know we already pulled out a 1, we're probably not going to have another one to pull out. So that means we've got 2's and 3's that we probably need to factor. However, if we didn't know that, here's what we could do. Using our rules for factoring trinomials, we have x squared plus x minus 6. That's going to factor into 2 binomials. Since our last number is a negative sign, is a negative number, that means one is going to be positive, one is going to be negative. Since our x here is the coefficient is 1, we know that these are both x's. We need the factors of 6, which are 1 and 6, 2 and 3. Since this is a negative sign, one of these is going to be negative, one is going to be positive. And it needs to add together to give me a positive 1. So that means the bigger one's going to be positive, and they need to be one number apart. Well, 2 and 3 are 1 apart. 3 needs to be positive, 2 needs to be negative. So that tells us that our trinomial is simply factors into x plus 3, x minus 2. So that means overall we have 3x, x plus 1, x plus 3, and x minus 2. And we are completely done factoring that. There are a few other options. If you don't want to use the rational root theorem, you can always graph the polynomial that they give you in Desmos, and then look to see where it crosses the x-axis. Those zeros, those are your factors, and you can use synthetic division with those zeros in order to figure out what the division is going to be and what the factors look like. The next thing you can do is you can use the special factoring patterns, difference of squares, sum or difference of cubes. And we're going to talk more about those tomorrow and what they look like. So with that, you do have enough information to begin looking at your 4.5 homework assignment on HRW. Good luck, Wildcats.